If only one bee was to cover the distance flown to make a 180-litre drum of honey, it would orbit Earth almost 2,000 times. There are some 25,000 bee species that pollinate most of the world's crops, but it's the honeybee that we use on an industrial scale. Around the world, honeybees are being wiped out by disease. Freighting honeybees from crop to crop, then crop produce from country to country, has helped to spread bee diseases internationally. If honeybees are in trouble, so are we. We rely on them to pollinate our crops. They rely on us for survival. This week, Earth Report travels to New Zealand to reveal the plight of the humble bee. Each spring in New Zealand, around 80,000 colonies of bees, about 280 million individual honeybees, are freighted into orchards to pollinate kiwi fruit flowers. The bees help to fertilise the plants by transferring pollen from one flower to another.
Things are getting wild.
Neil Mossop pioneered industrial-scale kiwi pollination. New Zealand is now the world's largest kiwi fruit exporter.
We have over 180 orchards we supply bees to, so we place in over 7,000 hives into orchards.
New Zealand relies on honeybees to pollinate most of its commercial fruit crops, also its brassicas, including turnips and radishes, carrots and a variety of seeds for export.
Yeah, we have to work at night because the bees fly during the day, and we don't want to leave any of our worker bees behind.
I'll see you in a couple of days.
In season at night, some New Zealand roads swarm with beekeepers trucking hives from crop to crop across the country. Across the planet, honeybee pollination is worth an estimated $2.7 billion. New Zealand's agriculture-based economy is underpinned by honeybees, literally at a grassroots level. They pollinate clover, which fixes nitrogen into pasture. Jim Anderton is Minister of Agriculture and Forestry, based at New Zealand's Parliament, the Beehive.
I mean, people talk about food miles, for example, and getting our produce, you know, from the bottom of the South Pacific to Europe, 12,000 miles or 20,000 k's or whatever. But in truth, because we have a pastoral system, in other words, grass-fed, we don't have to house the animals, we don't have to heat places they're in, we don't have to ship the grain. We have about a quarter of the carbon footprint, even after delivering our goods into supermarkets in Europe or America, that they do locally because of our different pastoral-based systems.
That pastoral-based system is now under threat from an invasion of the varroa mite.
To put it in context, if something happened to the agricultural base of England, about 0.5% of their GDP would be affected. If something happened to ours, it would be 20%, in other words, 40 times the cost to us as it is to Great Britain.
Thanks to international trade and industrial pollination, the varroa mite is now present in most of the world's honeybee-dependent regions. In New Zealand, its advance across the country is slowly killing honeybees by the millions.
Oh yes, lots of varroa in this hive. Having taken a quick look at the bees, I'm seeing bees with deformed wings or small abdomen. I'm seeing mites on top of the bees. For example, there's a varroa mite on the thorax of this honeybee here.
The varroa mite has already killed some 20,000 or 10% of New Zealand's managed bee colonies. Livelihoods have been destroyed. According to government figures, by 2035, losses in the South Island alone could be up to $344 million. By 2015, it's predicted there could be 72,000 fewer hives in New Zealand.
So this hive, without treatment, would be lucky to see out summer. Probably within the next month or so it'll collapse. So really it needs a miticide treatment put in it today.
For now, varroa can be treated, but at significant economic cost. Most beekeepers rely on synthetic pesticide strips inserted into hives in spring and autumn. The extra costs add up to about $30 a hive. Only the larger companies tend to survive.
We've had the varroa here for over 7 years, and we've increased our hive numbers quite dramatically since then. We work our hives a little bit differently. We have more staff, and we go around more often around our hives, and just got more mechanised and just more efficient in many ways.
But the varroa mite fights back. It typically becomes resistant to synthetic chemical treatments within 10 years of infestation. Varroa has been in New Zealand for 8 years now, and counting.
Oh yeah, you can see our queen here, she's an inseminated one.
In a government-funded project, Hort Research artificially inseminates honeybees to create a strain that can survive varroa infestation.
I'll pick some drones out of here.
If successful, this could avert a potential collapse of the beekeeping industry once the synthetic chemical treatments become ineffective.
So now I'm just going to collect the semen from this single drone. But I can't use that one because it's everted up onto itself and potentially contaminated the semen.
The idea to breed resistant bees came from overseas research, showing some honeybees have a gene that suppresses reproduction in varroa mites.
Oh, that's a goodie.
It appears to either make the mites sterile or prevent them from developing reproductively.
I'll bring her over, put her into the cylinder, and I'm bubbling a gentle flow of CO2, carbon dioxide. It's running over the queen bee now, which anaesthetises her.
After 5 years of selective breeding, Hort Research has created a honeybee strain that has 4 times more resistance to the varroa mite.
And now I'm going to inseminate her.
The problem is, once back in her hive, this queen could mate with 10 to 15 normal drones in a 2-kilometre radius. The varroa resistance in the bees could be lost in just 2 queen generations. Keeping varroa resistance levels high by artificial insemination can't be the answer. It's too time-consuming and expensive to be commercially viable. As the vulnerability of honeybees continues, industry is trying other ways to pollinate crops. On opposite sides of the South Island's Canterbury Plains, a research battle is underway. In one carrot field, an investigation into better bee management. In the other, prospects for artificial pollination. The outcome will help determine the honeybee's future.
Diane's been emptying pollen traps that we've put on hives. We're primarily trying to determine for how long the bees stay foraging on the crop that we've put them into, and that will help us make a decision as to when we place hives in a field, how many hives we place in the field, and for how long we keep them in there for.
Midland Seeds exports seed to 34 countries.
What we do makes sure that people around the world get food. If we can't make sure that the honeybees are working well, then we do have to come up with an artificial system to ensure that basically food supply continues.
So what we do here is we've been sucking the pollen off the flowers to collect the pollen, then we transport it to the other side and put it back on again.
Hort Research is responding to industry demand for research on artificial pollination.
The industry is looking much harder at artificial pollination for 2 reasons. Varroa has made beehives very expensive to use, so the economics of artificial pollination look much, much better. And secondly, again, in the long term, the real question is, can we guarantee that the honeybee is going to be there?
Kiwi fruit can already be entirely artificially pollinated. Last year, around 100,000 tonnes of kiwi flowers were harvested for artificial pollination. But resorting entirely to artificial pollination would do the honeybees out of a job. Without a role as commercial crop pollinator, they'd lose the human support they need to help overcome the varroa mite.
The balance between artificial pollination and honeybee pollination is always kind of a difficult one for any crop. In the end, it comes down to an economic argument for growers. They have to use the best system that's available so that they can produce the crops that they need. What we've seen in New Zealand so far is that it has always been to add on to what honeybees are doing rather than to replace them. Whether that's going to continue into the future, however, we really don't know.
There is one significant factor keeping the balance in the battle for pollination in the honeybees' favour. Honeybees make honey. Luckily for the honeybee, New Zealanders eat the most honey per capita of any nation. Plus, New Zealand ships out tons of honey. In 2006, the value of honey exports exceeded $30 million. At this factory, honey processing is a science. Samples from across the country are analysed for pollen content, conductivity, sugar spectrums and pH levels before being combined into 10 varieties.
We bring that back into the lab, standardise it across so the consumer ends up getting exactly the same, for example, Manuka honey with the same flavour, the same quality, same characteristics again and again, and that will match the norm for Manuka honey.
Manuka honey is now the most prized variety on the shelf. It was once considered almost worthless.
Since 1989, the sales of Manuka have grown quite dramatically because of the health properties of it. Back then there would be virtually nothing sold, not even harvested because it was difficult to harvest, whereas today there's something in the order of about 2,500 tonnes of Manuka or honey sold as Manuka in the country.
Manuka is now the cash cow of the New Zealand beekeeping industry. Its success is helping secure the honeybees' commercially dependent future.
Oh yes, they filled it up nicely.
Manuka's status started changing in the late 1980s when Dr. Peter Moland confirmed it had unusual medicinal properties.
I'll do the age-old process and just give them a shake. Yes, don't want to take me back to the university with you.
While Manuka had long been used medicinally by Maori and the ancient Greeks noted honey's medicinal properties, Manuka honey didn't exist until European settlers brought the honeybee into New Zealand in the 19th century. Regular honey contains the antibacterial agent hydrogen peroxide, which is quickly destroyed by a human enzyme. Dr. Moland's research showed that active Manuka honey also contains what he calls UMF, the unique Manuka factor. Active Manuka honey can help heal wounds when other treatments fail.
Probably the most remarkable case would be a teenager who'd had meningitis, and he'd had 8 months in intensive care because of the horrible sores he had, and we had him home in 2 weeks of starting using honey dressings.
Manuka honey dressings are now widely used in countries such as Britain, Australia and Iraq. Amazingly, Manuka honey combats the antibiotic-resistant superbug methicillin-resistant Staphylococcus aureus, MRSA.
For MRSA, honey has been realised to be the answer because it is fully effective against that and gives very rapid clearance of MRSA from infected wounds. And since then I've gone on to looking at the other ways it works, because it's not just its antibacterial activity, it speeds the rate of healing, it stimulates the growth of the cells to repair the wound. Honey will work on any wound at any stage.
Traditionally, the Manuka bush was regarded as scrub and cleared to make way for pasture. This contributed to the decimation of New Zealand forest, from 85% land cover to 23% since human settlement. The lack of Manuka clinging to hillsides is one factor responsible for widespread soil erosion and land degradation. There are now 1.45 million hectares of marginal pasture land in New Zealand. Increasingly, landowners are choosing to keep or even plant Manuka so they can earn revenue from it, renting land to beekeepers like Neil Mossop.
There is a small amount being planted in some blocks that I've heard of, and marginal land that is not producing very much for sheep and cattle. They're actually leaving it there, and we pay a fee for having the bees on the property. I know some of my farmers can make more money out of us paying the fees than they do out of the wool clip.
Manuka's role in forest regeneration is important. As a nursery plant, it's one of the first species to grow. Its presence then supports the colonisation of other species. Over time, biodiversity is greatly increased. The New Zealand government is now sweetening the deal even more with the Permanent Forest Sink initiative. Now, commitments to reduce carbon emissions under the Kyoto Protocol can be honoured by planting or maintaining existing forest, including Manuka. Landowners then earn money by selling credits for the carbon their trees absorb.
You've now got a coming together of the economic benefit of Manuka for honey production and the climate change issues under the Kyoto regime. So there's going to be almost a double whammy for growing Manuka.
As prices soar, beekeepers scour the country in search of new Manuka stands.
Now we go out of our way, we take hundreds of hives into remote areas, up remote valleys, up river beds with four-wheel drives, just seeking out manuka blocks and to put our bees as close as possible to the manuka.
This means that plant species away from orchards with no direct commercial value can be pollinated by the managed honeybees, a job previously done by the wild honeybee colonies which, without treatment against the varroa mite, have largely died out. Beekeepers are keen to avoid new threats to their little earners.
Hey Mark, can you get the guys down here? We'll take these ones next.
In order to prevent more diseases and pests like varroa from entering New Zealand, they would prefer that trade went one way, out.
This never happened before. Hey Dwayne, hey!
In 2007, the New Zealand National Beekeepers Association took the government to court over its decision to allow Australian honey into New Zealand.
The Minister of Agriculture can destroy our industry by a stroke of a pen by allowing honey to come into the country, which they already have done. They've allowed it, then we took it to the High Court. What I would like the Minister to do is not allow any honey or bee-related products to come into New Zealand. And that bee really stung me on the lip.
We're an island nation. We have a lot of security in terms of our position and way down here in the South Pacific. But we're still on the planet and we're subject to all the things that happen there. And because we are the most dependent trading country in the world on agricultural-based production, we've got to be very, very careful that we use an evidence and science-based approach to biosecurity. If we start telling other countries that just by whim we won't take their goods because we think there is a risk of some substance or organism coming into New Zealand, then the world will turn on us and do exactly the same to us. And guess what? 4 million New Zealanders need 7,000 million people more than they need us.
In December 2007, the High Court ordered that Australian honey imports be suspended. They upheld the National Beekeeper Association's fear that honey contaminated, for example, with bacteria, could bring new diseases into the country. Some feel, however, that regardless of trade policy, invasion is inevitable.
With the international trade the way it is, these diseases spread very quickly around the world. To kill a colony in Europe takes about 2,000–3,000 varroa. In New Zealand it takes 40,000 to 50,000 varroa. The difference probably is all these other things that are going on, these other pathogens and that are present in the hives. So at the moment, although varroa is this devastating pest and a huge problem for us, it could be much, 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 much worse than it is currently. And unfortunately, sometime in the future, it's likely to be.
If isolating New Zealand's honeybees from disease proves impossible, court research can at least separate the best from the rest. They're loading their selectively bred bees to take them to a remote island. Once isolated on Great Mercury Island, 5 kilometres off the Coromandel coast, court researchers' bees won't be able to mate with normal drones. Their enhanced varroa-resistant bloodline will stay strong.
Honeybees' existence in New Zealand is now dependent on human beings. If we're not here, the honeybees aren't here. Previous to that, if we weren't here, the bees probably may even do better, but our futures are linked now.
Court research hopes that their queens, with a support staff of 50,000 drone and worker bees, will found the world's first highly varroa-resistant, self-sustaining honeybee community.
4 hours ago, there was no varroa on this island. We've just brought them. But what we're expecting is the bees to eradicate it from these hives. I'm not quite sure what's going to happen at this point because I'm going to let them go. So you probably may not want to stand too close.
If all goes well, these bees and their descendants will be able to help avoid a disaster when varroa becomes resistant to the synthetic pyrethroid treatment which beekeepers now rely on.
Hopefully they'll stay here and mate, and the genes that we've selected will increase in frequency and we'll have a very good resistant stock at the end of it. The next step is to provide it back to the beekeeping industry in New Zealand so that anybody who wants to use it and incorporate it into their own outfits can gain the benefits of the resistance that we've developed.
Now this is the nirvana of the varroa problem. I mean, this is world-breaking research. If we can crack this, we'll crack it for the rest of the world. We should patent it and don't give it away because it's worth gold. So yeah, it's good news.
Varroa has spread almost all around the world. But while there's new hope in New Zealand, it's just one plight of the honeybee. Amongst other ailments, North American hives have been struck by the mysterious colony collapse disorder, CCD, where bees seem to desert their hives. Beekeepers report hive losses of up to 90%. It could have numerous causes, including viruses, bacteria and parasites. Not enough is yet known to help the bees.
Everything we do in New Zealand and worldwide is not sustainable long term. And you see the big losses that are happening everywhere in the world, and we really need long-term solutions, and this is at least a start at a long-term solution.
With the movement of Varroa into new countries, wild honeybees can't survive. Managed honeybee colonies now depend on the beekeeper to stay alive. In the future, industrial-scale pollination by honeybees will depend on the success of research programs worldwide.